Hello, can you hear me? Testing, testing. Hello, Quinn. Yes, no? How we doing?
Sounds fun.
Cool. Can you see me? Oh, yeah, we can. Oh, there's a delay, right. We good? You see a bunch, sure.
Hello.
Alright, sweet. Alright, you can mute me now. I don't want to hear myself 1 minute in the past. Cool, let's get started. So, thanks everyone for coming today. We'll be learning OpenCV, which is, I don't know if you guys have heard it before, it's a library that we can use to do things like image processing and computer vision, right? So just before we start the workshop, I'd just like to thank our sponsors. So yeah, all of them here. Cool. So let's start off. What is computer vision? Can anyone tell me what they think computer vision is? Tevin? Come on. I'm going to call on you. What do you think computer vision is?
I think computer vision is a functionality for a computer to analyze image, to make interpretations to it, and to even make communications based off of interpretation.
Yeah, so it's basically we take some sort of image or video, right, and we have to interpret it, turn that raw data into something that we can actually use as information, right? So yeah, it's a rapidly growing field, like a lot of research going into it, and there's like a wide range of applications from self-driving cars. Facial recognition is another one which we should be able to get to today, hopefully. If not, we have a. You can have a look at the recording of the previous one. Cool. So yeah, as I said before, OpenCV is an open source library, and that has like a bunch of tools and algorithms that you can use for image processing, right? It's usually in Python or C++, so today we're going to be doing Python. It's a bit easier. Yeah, and we're basically going to do a bit of an introduction to OpenCV and see how we can use it to do some basic image processing. Oh, that got messed up. So yeah, we'll get started with OpenCV. So this is just like installation, all that stuff. That might take quite a bit, so we'll be walking around if you are unsure of how to install it. Then we're going to be doing some real-time image processing, right? So we're going to be using your webcams, which I'm guessing all of your laptops have webcams, so that should be good enough. Yeah, and we're going to talk a little bit about cameras, because of course we need cameras for actually getting our images, right? And it's really important to have the right environment to get your image. Otherwise, yeah, if you don't have the right image, garbage in, garbage out, you won't get that much meaningful information out of it. Cool, and then after that, we'll be talking about camera calibration in context with using that for Aruco tags. So those are like little QR tags that you can use, and that lets you find the position and orientation of any object that you place it on. And then finally, if we have time, yeah, we'll go through some face detection. Cool. So just to get started, I'm guessing everyone has Python installed, hopefully. Yes? Does anyone still need to install Python? No? All right, sweet. That makes it easier. Then next step, of course, if you're in the command line, you can run pip install OpenCV Python, right? So I'll give you a bit of time to go through that. Also, you can, yeah. It's pretty chill, so don't feel like I'm just giving a lecture. I'll be going around if you have any questions. And yeah, Quinn will let me know if there's any questions online. I'm not sure how many people are watching the stream. Two. Sweet. Yeah, if they have any questions, let me know. It might be a bit delayed, but that's fine.
Yeah.
Cool. So yeah, how are we all doing? Installing Python. What do you mean? No. Yeah. So OpenCV, you can install it using pip, which is a package manager for Python. Yeah, you just literally run pip install OpenCV Python. That should give you all of the basics. So, how are you guys going? Oh, you got the, yeah. What is this, path planning? Very cool. Very nice. And yeah, for those of you who are done, you can check out our GitHub page. I think it's just UQ Mars, and have a look at the workshop resources. All of the resources and code for tonight will be up on there. Of course, you can just download it, but it's more fun to code it by yourself, line by line. Some of the later demos, of course, they're a bit more complicated, so we don't expect you to type that all up. How you going? Pip install, does it work? No. Pip, just try pip. Yeah, so if pip3 doesn't work, try pip. Did you install Python? Try to do Python. Go to Python. Yep. You don't have Python installed. Yep. How are we doing?
Yeah, all good. I had it installed.
Sweet. Oh yeah, true. How you going? Is that
good?
Yeah. Yep. Cool. So yeah, once you've installed this, just go and check your installation by running Python, which should open up a Python environment, and then you can run import cv2 as cv. That's just going to call it cv in our namespace, so we can access it using cv dot something, and just check your version. It's a good way to check. Yeah, let me know if you're having any troubles installing it. Yeah. So quiet. Why are you guys so quiet? Concentrate. No, I appreciate it. This is quieter than my classes. How are we doing? Good? All right. Yeah, and so for those of you waiting, check out the GitHub. You might want to do that because there's like quite a lot of code for this first demo. How are we doing?
Yeah, good.
Able to install?
Yeah, I have to reinstall Python stuff today, so it's still doing
Yeah.
Um,
Using PyCharm, yeah.
yeah.
Cool. We'll just give you a bit of time. Yeah, PyCharm's fine. Just make sure you're using the right like Python environment.
Yeah.
Yeah. It should just install it directly.
Yeah.
Yes. CV2. Sorry, that's a double underscore.
Okay.
Yeah, that's all. There we go. Sweet. Cool. How are we doing? All good? Got CV 4 point? Yeah, I don't know. Version 4. Yes.
I'll do it slightly on my laptop, so it's pip.
Pip install OpenCV Python. OpenCV dash Python. Oh, sorry, OpenCV dash Python. Yep.
So
Should work.
doesn't matter if pip3.
Pip3.
Oh, no,
Either pip
I
or
don't have
pip3.
internet.
Oh, okay. Yeah, that might be why. Yeah. It doesn't. Pip3 makes sure that it's Python 3.
The thing.
Yeah.
Oh, the Python install. I missed it.
No, it should just be pip install.
There we go.
CV2.
Sweet.
Pip installs.
Just make sure that it's like Python. It's a shortcut for Python 3. Pip. You should be in Python 3 on this. Yeah. It's just like some computers have like Python 2 by default. It's weird. But yeah, most more modern ones have Python 3.
Alright.
Cool. How are we doing? Yo, was that Ted's? Nice.
Help me install.
I'll get you. I'll help you.
We went
You already
to
got
a
it.
workshop.
Yeah, I remember last year.
Oh, you don't do this inside.
We are
Python.
here for Mars.
Oh,
You do this.
Thank
with
you.
Python.
Appreciate it.
Bombshell?
Yeah.
How we going?
So you can just.
All
make
good?
it there and then
Cool. Anyone still
because you're in
stuck?
terminals.
Ooh, yep. How we doing? Yep. So yeah, just run import CV2 as CV.
You still need to restart it after you do it.
Yes.
Anyway, but yeah, open a terminal.
I think there's no module found.
What is CV2?
I thought I installed it.
How'd you install it?
I just did pip install.
Might be try pip3
And then.
Yes.
Oh.
times.
Pip install.
Oh,
Open.
wait. So Python. It might be running a different Python environment, like different Python executable than what was on there. Because you're using this. Oh, that's just VS Code.
Because I thought it was like you download it in Python.
So this doesn't work. Oh, wait, yeah, this is VS
Download
Code.
it to the computer.
Okay. So how are you running this?
Once this is finished, you can just.
Ah, okay, no, don't do that. Do Python 3
terminal.
CV stuff. That should, yeah, that works now. Oh, you didn't print it though.
I'm
So
assuming
yeah, if you
you've
run
got
print,
three.
eh, you can type it.
I
Print,
do have Python.
and that should work now.
Yeah.
Yeah, so make sure, yeah, when you're running it, run it using Python 3, because if you use the default VS Code thing, it'll run a different Python environment.
Oh, okay. I was just doing like
Give that a go. There we go, sweet.
Just that.
What did you found? Did you run
And then
pip install
check
Python?
it's like,
Oh, okay. Did you just come here? Okay. Sorry. For those of you who just came and missed it, you can install OpenCV by running pip3 install OpenCV Python.
CV dot under version under
CV
Oh yeah.
under dot
dot under.
Hello, sir.
version.
Yes, please. You can get people to install Python. You're a 42 tutor.
Just
Oh,
What do you mean? No.
oh sweet.
Cool.
I don't
Everyone
remember if
good?
that's the version you wanted, but-
Yep. Sweet.
So could you just
Sorry. We
install
able to?
the-
Yeah. Do you want to help?
unless
Let's catch up.
No, well it'll install the most up-to-date version of it. By
Cool.
default.
Oh, okay. Sweet.
All right, so yeah, now we're gonna start with a bit of an introduction to image processing, which of course is the basis of computer vision, right? You need to be able to manipulate images in order to interpret them. But it's, yeah. So image processing is the manipulation of digital images with like algorithms, right? It has a deep root in stuff like signals and systems and digital image processing. Like if you want to take those courses at uni, we offer them, of course, but yeah. We can also use digital image processing in other applications such as medical imaging and, yeah, of course, computer vision, right? So today we're going to be using image processing on a webcam feed in real time, which is pretty fun. Cool, so let's get started with what is an image? So an image, right, obviously it's something that you can see, right? But essentially it's a two-dimensional signal, right? So if you think of audio or like a voltage, that's a one-dimensional signal, right? The one dimension being time. With images, we have two dimensions, right? We have x and y, yeah? And so at each of those coordinates, we assign a value to that coordinate, right? And for digital images, those are, of course, called pixels, right? In terms of pixels, they usually are, they're usually in color, right? And so that color value is stored as three different values, one for red, one for green, and one for blue. And that corresponds to something close to human vision, right? And of course, that gets outputted on your screen as individual subpixels, right? So once we know that, we can sort of treat images as essentially an array, right? We have a two-dimensional array of values, which we assign according to the color, right? And then we can manipulate those values however we want, right? And that's what image processing is. Cool, so let's get started with some demos. I'm gonna just exit out of here and bring up this. Cool, so I'm just running this in VS Code. What? Why can't I drag that over? Is it coming over? Come on. Why can't I drag this over? Okay, I might have to change this to the display thing is not working. Extended. Yeah, I'm just gonna change it to a mirror. Cool. Can we all see this? So I'm just gonna run this demo code, right? And let's have a look. Python 3 intro. should pop up with a window. Cool. So, right, as we can see, this is our image. It's made up of 3 different channels. So the red, green, and blue channels, right? And let's just dig through our code a little bit here. Right, we're just creating some windows, right? So these 2 functions just create our windows which we can display our images in. You don't have to do this, but these are the main things, right? So what we're doing first is we're taking our image and reading it. So if you have like a PNG or JPEG, right, you can type in imread. So cv.imread, put the name of the file, and then write cv.imreadColor to read it as a color image, right? So if I were to get any other image, so I'm just going to drag this Mars logo, why not? And just chuck it in here. Let's go back here. So for example, if I was to do this, so I'm creating a image variable called image Mars. That's equal to cv.imread. And that's Mars logo.png, right? cv.imread color, right? Now I have a variable which is storing my image. And what I'm going to do first is I'm going to print it out, image Mars, and I'm also going to display it, right? So this is reading it, and the next part is displaying it, and that we do that by running this command imshow, right? So cv.imshow, I have to put the name of the window to display it in, so I'm going to call that Mars. All right, so show the Mars logo. Mars logo. And it's going to be image Mars, right? So let's run this again. I have to close this. Sorry, I missed one thing. So after you show an image, in order for it to actually display and like sort of stay there, we need to type in this command wait key. And by leaving an empty argument in here, that's just going to wait until you press any key. And then it's going to continue on with the rest of the code. So I'm just going to run that here, and let's just see what it looks like. Cool, that's it. So as you can see, it's printed out our image as an array, right? We can see it's mostly zeros. Yeah. We do have some other values there, which they aren't showing up right now. But we can see that our image, right, if we go, if we run this again, so I'm going to print out the shape. And for those of you who haven't used NumPy, this is how you access the dimensions of the array. Right, so we can see that the image is 1132 rows by 3878 columns, and there's 3 channels here, right? And we can see it's just displaying the image. Cool, so let's give a bit of time for you guys to experiment with reading different images in, right? And then we'll move on to the channels, explaining the channels, and some basic image manipulation. Hello, what's up?
How did you so to run like Python 3? Do you have to?
You're already in Python.
So I mean, like, how do I access the? How do I open it in the editor?
Oh, do you have an ID?
I do, but like, I'm not using this code.
Oh, yeah, just create a folder. So yeah, open a folder, create a new folder, get into that, and then create a file, a Python file. So just curious, how many people here already have some experience in Python? Just raise your hand if you have experience in Python. Has anyone never seen Python before? You, okay. Or any code at all. Because obviously it is a bit tricky, but it's good if you have some Python experience. No. Yeah. I don't know. Yeah. How we doing?
Because I'm just kind of like, when do we get to recognizing shapes and stuff?
Recognizing shapes.
Like just like image recognition and stuff, or just object detection.
Object detection's not, this is an introduction. Usually the second workshop does object detection.
Oh, whoops.
Yeah. We are doing, not object detection, we're doing, I guess camera, like position detection. So like working out the distance between two objects, or working out the transform between the object and the camera. We are doing that today.
Oh, no, that's cool. It's still cool.
Yeah. We're not doing, we're not doing like recognition till later.
Yeah.
Hoping to do another workshop. Like last year we had 2 workshops in this, because you know obviously computer vision is a very broad topic. Yeah. Cool. Is everyone able to display an image? Struggling a bit. We can slow down a bit.
Sorry, no, where is GitHub?
If you search up UQ Mars,
Yeah.
is it not showing up at all? Go to repositories. Is it not? Is it a private? Quinn?
No.
No,
No. Why
it
can't
should just be workshop resources.
but UQ Mars isn't showing up on repositories. Oh, users. Sorry, users.
Yeah, organizations.
Organize. Yeah, same thing.
Yeah. Cool. Thank you.
And should be workshop resources there,
Yeah. Sweet.
and then CV.
CV. Of course.
Yep. Open CV.
Oh, I just now navigating to that.
Yep. For those of you struggling to find it on GitHub, just gonna get a new window open. So, GitHub. Yep. Sorry, UQ Mars. So it should be under UQ Mars and users. So just through here and then workshop resources. So I'm just going to run this again. Cool. So what we're doing first is we're creating a grayscale version of that image, which we'll see in a bit. And we're actually taking the different channels of the image, and we're just displaying the different channels as red, green, and blue. Or in this case, it's actually blue, green, and red. For some reason, OpenCV is like switched around, but don't mind that. And then we're just stacking them together in a single image. All right, this just combines any images or any arrays together. So we can then show the image like this. All right, so let's just go through how I did that. So if you want to change color or change the color space of an image, so for example, if you want to convert from a colored image to a grayscale image, we can use this command called cv.cvt color, so convert color. And that just takes in your image and a code here. So this is going from color to grayscale. This will then convert your colored image to a grayscale image, right? And what I'm doing here is just converting it back to a color image, except not really. So I'm not sure if this is, this might be a little bit confusing, but we're basically taking our grayscale image and then just converting that back to the RGB equivalent to keep it as a grayscale image, but still represent it with 3 different values. And that's just so we can then display them all together in one image. Cool, so here I'm using the copy command as part of NumPy to copy the image, and then I'm setting this the image channels to 0. Right, so you might notice, right, this is an array with 3 different dimensions. The first dimension being the rows, the second being the columns, and the third being the channels. So what this is saying if you're not used to NumPy, this is saying
Take all of the rows and all of the columns and take the first, or the channel 1 and set that to 0. Yeah. And same thing for channel 2. So this is going to set the green and red channels to 0, right? And then same thing for green and blue, green and red. And then again, I'm just converting them back to a BGR image so we can then display it together. This doesn't actually affect the image that much. And let's have a look at this, right? So this is the image that it outputs. Again, we were just taking this original image, then getting rid of all the red and green for this, getting rid of all the blue and red for this, and then getting rid of all the blue and green for this, right? So we're just left with the blue, green, and red channels, right? And we can see that, yeah, we have dark values for when there's not much blue. So the color red here doesn't have much blue, so we can see that this part of the lorikeet is dark, right? And same thing for the green. We can see that the green is right around here where it's green on the lorikeet. And then finally, yeah, for the orange, we have a little bit of green and a little bit of red, right? And yeah, for this part up here, right, what is white made up of? It's made up of red, green, and blue. So combining these 3 colors together, we get this top part here. Cool. And of course, we can see that in grayscale as well. So this is the grayscale image. Yeah, we have bright areas where we have that color, that corresponding color in the image. Right? Does that sort of make sense for images? Yeah. So yeah, because these images are just represented by values, we can do a lot of things to manipulate them. So yeah, this has a lot of applications, not just in computer vision, but anyone who does like videography or photography, right, or anything that your smartphone does to process your photos, that's all done through computational imaging or image processing. Cool. Is everyone able to run this first demo? Anyone still? Yes? Not working? Oh, good. Let's have a look. Demo is not defined. How are you running it? Is R using idle? There we go. Yep.
Because I reordered
Yeah. Directory, yeah. Yeah. Cool. How's everyone else going? How you guys? Are you able to run it or no?
I think I've somehow
It's the install that's.
screwed up the installation.
Let's have a look. Unable to create process.
Yeah, but then I went into the settings and it's
Right. Oh, yeah. So Python, does that work? Oh, Python 3, does that work?
yeah, I should have.
Which Python did you install?
I got 3.10 this afternoon because MediaPipe wasn't working with 3.11.
Oh. Python 3?
That's weird. All right, well, I'll sort that out.
Does this?
Yeah, so that I'll just do a quick hello world and that works.
Oh, that's this one.
Yeah.
So you, yeah. Yeah.
So go back to Git. Ah, yes, it's got the name.
Is it running? Oh, there. Okay. What's the error? Oh, yeah, I know why. It's because you don't have the name. You don't have the bird image.
Oh, really? Okay.
Yeah, that's why. So it's just looking for. Yeah.
Right. But
It's looking
weird
for the
that it
bird
has
image.
all of these reference errors too.
What?
Are these highlighted ones?
Oh, that's fine.
Okay. Yeah,
That's just their interpreter being.
I'll get the bird.
Oh, so
image
that's
then.
yeah, that's just your IDE being weird.
Alright,
That's fine.
cool. Thank you.
Yeah, but yeah, you just need to get the bird image. How are we doing? Is this DRC? Yeah. You guys using OpenCV for that? Yeah. CV all over this stuff already.
Yeah, I got pregnant.
Sweet. That's it. That's a red cat. Cool. Oh, sorry. Is that
Thanks. Sorry, this is the part, I was having trouble getting the installation button. Now that I got
Sweet.
it working, what did you want me to mess around with?
just reading different images in, if you know how to do that. I think you got it. It's just changing the name of the file.
Oh, sure. Like,
Yeah.
like wouldn't I need like a file?
Yeah.
It's like, yeah, because there's only a first.
Do you have the bird? Oh, you did.
So what is it saying?
Oh no, it is. It will be displaying. It's just might just be hidden, or not. Weird. So if you run this,
Try running it in terminal.
is this not in the terminal?
Well, it's just terminal.
Yeah. So is it print? Is it doing anything?
Whatever. I don't care.
No, it's not even running that. Which directory? Intro. Weird. What? It's not doing anything. Oh no, it's this. There we go. Sweet. Did I actually put that?
No,
swear
honestly,
I
I
did.
might have
Changed it.
Oh lol. Okay.
My bad.
Yeah. Good. How are we doing? Is it?
Not working? What's going on?
It's pretty funny. Yeah.
I mean, I think it says something about how bad the internet is.
Cool. I think we've all got the hang of that. Cool. So let's go through some basics. Now that we've done this, we're going to go on to the second demo.
So let's run through this line by line.
So in this demo, again, we're reading the image of the bird.
Right, so that's displaying as this, right? The next step is converting to grayscale, which you've seen. Right, so that'll give you this, right? So again, we use convert color.
Pass in the image. Go cv.color.
BGR to gray to convert it to grayscale, right? And then show the image, right? This next part is pretty cool. So now we're going to crop the image. So sometimes it's useful to not just deal with your entire image, but to crop it into some region of interest, right? And by convention, we define that region of interest as an x and a y coordinate, as well as the width and the height of that region, right? So I'm basically going to call, image cropped will be equal to the image, and I'm using Python array indexing. So
This means we're going from a y to y plus h, and x to x plus width, right?
and you might be wondering, why are you doing y and then x? Well, that's because with Python, and in fact most arrays, they're indexed by row and column, not x and y. So that'll be y then h. Cool, so that looks like this. So that's the cropped image. Yeah. This is a pretty good crop, if I do say so for myself. Cool, so if we wanted to do something like
I don't know, eye detection or something.
we could crop into the animal itself or the person, and then we could find where that eye is in a smaller region. Cool.
Then we have resizing.
So resizing, we use this function cv.resize. Yep, so resize, you pass in the image and the size that you want to change it to. So I think the original image was 512 by 512, and I'm resizing it to 128 by 128. So it's tiny. And of course, if we blow it up, we can see how pixelated it is. Right. Another thing with this resize function, you can pass in the type of interpolation. So if you're not sure what that is, that's, I guess, what rules it uses to scale the image up or down, right? So, yeah. So one example is using cubic. So cubic, when you resize it, it'll give you a very smooth image when you make a big image. And I'll show you the difference. So I'll just run this again. So I'm going to take this resized image and then resize it back to its original. And I'm going to resize it using using cubic, right? So we can have a look at what that does. So I'm just running it again. Oh, sorry, I didn't. Don't mind. And yeah, cubic. So we can see our original image is over here, and this is the upsized version. So sorry, upscaled version. It's a bit hard to tell, but it's sort of blurry, a little bit blurry if you look into it. Whereas if I use a different method of upscaling, so another one is using inter-nearest. So this will keep things pixelated if they're already pixelated. Cool, so that sort of keeps the pixelation there. Oh. Cool. What's next? The next thing we're going to go through is setting values in an image, right? So sometimes we want to modify specific values in an image. So one example is using it to mask out an area. So we can do that by literally taking that region we want to set to a value and then set that to whatever color we want. So in this case, what I'm doing is I'm taking a region at 100 by 100 of a size 50 by 50, and I'm setting that region to gray. So, so I'm just setting the eye to gray, and that's just setting these values here. So if I were to change them, I don't know, let's say I want to set it to green, I could do that as well. Yep. Does that sort of make sense? Cool. And then next, we'll talk about evaluating, so setting values based on some sort of condition, right? So if I want to set all the values that are below a certain amount or equal to some pixel value, I could use this here. It's a bit hard to do. I might do this. Yeah, let's go. I'm going to create a copy of the grayscale image. Right, and then I'm going to evaluate when that image is less than 128. Oh, sorry. So it's going to be this thing here. Oh. Image clipping gray. We're evaluating that for when the array is less than 128. Right, and then we want to set that to, I don't know, let's set it to, set that to 128, right? And then I'm going to show this image here. Cool. So we can see that's basically clipping our image so that any values that are less than 128, so that's like the midpoint of gray going from 0 to 255. So any values that are less than 128, I'm just going to set them to 128. Yeah, I can also do this if I set it to 0. Let's do that too. Oh, I missed one. Sorry. But there it is. So all those parts of the grayscale image here that were below 128, I'm just setting them to black. Yep. Does that sort of make sense? Right, this is a form of, I guess, masking or thresholding. So we're evaluating some condition on the array, right? And then we're setting the values that, the pixels of that array that meet that condition to a certain value. All right. So one application of this is checking if your image has clipped. So that's when you have really bright parts of your image or really dark parts of your image that you can't see. Right. So in this, I've done it for when the brightness or when the average brightness is equal to 0 or 255. That's when the image is clipped to the whites or the dark parts of the image, and I'm just setting those to red and blue. All right, so we can see this region up here. If we check the pixel values, the average is around 255. So that's why we've colored these in red. So that's this part here, coloring it in red. And then the really dark parts of the image around here, I've set those to blue. Cool. Let's give you a little bit. I'll have a walk around, see if we have any questions about this sort of stuff. How you go on? Clipping.
I should change the threshold to. Let's try.
Well, that's the value that you're setting it to.
Oh, right,
Yep.
Sorry. So if
So yeah, you can do any condition. So yeah, you can do less than, you can do equal to, you can do
oh, okay, so if they're equal to.
double equals. Yeah.
If they're equal to 120, I'll set them to 0. Just because.
Yep. So we'll find all the parts of the picture that have just that middle value.
Yeah. And then 0. Is 0 what?
0 is 0 is black.
Why isn't it?
It's just slow. I don't know. Let's try it again. Closer. Yo, it's a nice cat. Not Burb. Oh yeah, so that lorikeet photo, I actually took that when I was in the park. Thought it'd be a good photo for this demo, since it's got all the colors. Yeah, I do photography. If yeah. Thank you. My Instas. No, I'm kidding. Yeah, it's the same as my GitHub. So yeah, try this out in any image. Just for the sake of time, you can keep playing around with that, but I'll start running the next demo, and this one is about more general filtering methods that we can use. So instead of just like basic, the core image manipulation, we're looking at different filters. So for this one, I'll be using a webcam. Cool. And I'll show you how we can get that started up. But essentially, this is the core. This part here. I'll bring it down actually. So basically, you just want to run. I don't even need this. You want to run these in your code, and this is basically gonna display your webcam. Wait, I know I'm missing something. Where's cap? Here we go. So yeah, if you want to access your webcam, which you probably would want to do, especially if you're using a webcam on like something like a Raspberry Pi, right, for maybe a droid racing competition. I don't know if anyone's doing that. But yeah, this is how you would access the video feed in OpenCV. So you create a capture object and you do cv.videoCapture. And this number in here is going to be the device number. So if you have multiple webcams, you might need to put in 1 or 2 or even 3 if you have 4 webcams. And of course, the indexing starts from 0, right? We're not MATLAB people, we're Python people here. I'm kidding, MATLAB's fine. I wasn't paid to say that. Cool, and this is just checking whether it opened up properly. And we've just got a huge while loop here. Just gonna change this, one sec. Yep, so we got a while loop, and this is just reading in our image, cap.read. So if you want to just get your webcam working, try running just this part here. Plus you also need the imshow bit, but yeah. And I'll show you here. So this is our original image. Very, very high detail, I think. Could be better. Maybe I'll use my phone. Let's try using my phone. I think it's number 2. Ooh. Ooh, yes, it works. Haha. No, okay, hang on. Anyone get an iPhone charger that I can steal? There we go. Just gotta plug in before it runs out. No. Oh, you don't need that. Just get rid. So, I mean, you could use it. Yeah. If you want, you can install Perlin. It shouldn't take that long. So again, using pip. I think I put a thing up on the. Oh yeah, run this command. So I've already run it, but if you run that, it should install Perlin, and you'll need that to do one of the cool filters here. But if not, I'll show you which part to delete. It's just, it gives you an old-timey look. There we go, okay. Is it working? The webcam? Yes, it's working. Haha, wireless webcam. Yeah, sort of, it's charging. So this is my webcam now, my phone. Yeah, entirely wireless. Wireless? No. It's gonna be wireless. Come on. Come on. Oh, it's low battery, that's why. Fine. Doesn't want me to do it wirelessly. Cool, so, come on. There we go. Cool, so what I'm doing here is I'm running a bit of real-time image processing, which is just a fancy way of filtering. Cool, and this might look a bit crazy, but what we're doing here is we're applying what's called a filter kernel, right? So if I press space, you can see it changes. So that was a sharpen filter. This is an unsharp mask, which sort of blurs out the edges. This is a box blur, so just a type of blurring. A Gaussian blur, which is another type of blur. A larger Gaussian blur. A Sobel filter, which is used for edge detection. So we can see all the edges are very prominent. Yeah. Anyone want to show themselves. Sobel filtered. I'll do it. Yeah. Yeah, damn right. Yeah. All right, Quinn, you got to get in here.
Yeah, this is
Oh, you can see most of the logo in there.
wait, was it? Oh, there we go. Bit of UQ Mars rep. Yeah. Yes. Okay. Ah. Yeah, okay. If you don't have Perlin, you will have to
Just install Git.
just do it. Nah, this part here.
Just get rid of image Perlin. Just comment this out. Perlin. Yes, obviously get rid of the import if Perlin's not working. I think that's it. Oh, this part, sorry. So anywhere that has Perlin, just comment it out. And that should be the same. And then just change this.
Yeah, change grainy to just, I don't know, change it to sepia.
Sepia? Sepia, I don't know. So anyway, this is the Sobel filter. This is the sepia filter. Right. Looks like old photos.
This is an old-timey filter, which is applying a bit of film grain onto the video feed.
I don't know, what's something very old-timey? Does anyone have a monocle or a hat? Top hat? Nah. And yeah, this next filter here is called a threshold. So that's
Very similar to what we did before, except we're just setting it to a binary value. So if it's above,
the threshold, or if it's between two threshold values, then we can set that to a value of 255,
or 1, basically, all ones.
or we can set it to 0, right? So it's basically on or off. It's binary. And that's using this threshold operation here. Cool. So let's go up here and talk about this just a little bit. All right.
So what we have here are
These things called filter kernels, or kernels, right? And what that does, if I just go onto the Wikipedia page, maybe.
kernel.
Kernel image processing. So, yeah, essentially we're going to apply
A convolution, which is a scary word for just sort of
smearing that that kernel over the image, right? To apply a filter here. So this one here is called the identity. That's not doing anything. So when we apply this kernel, it's going to result in this exact same image.
we can also have edge detection filters. What that's going to do is it's going to take the difference between the current pixel and the neighboring pixels, right?
And if that difference is,
Has a value greater than 1, that means we have an edge, right?
so if it's something like,
Negative, positive, negative, right?
we can imagine that on the edge, right, we're going to have a sharp transition, and that's going to cause a high value for these edges, right? Same thing for sharpen. So the sharpen filter just takes this edge and just like
Adds it onto the original image, right? We can see it's just equal to this identity plus this edge detection filter, right? That gives us our sharpening filter, which accentuates the edges of the image.
we also have what's called the box blur, which
We went through before, and what that's doing is it's taking a region of the pixels and then averaging all of the pixels in that, and then setting that pixel in the new image to the average of those pixels. So you can kind of imagine that averaging a region of an image would cause it to be blurred.
right, it's going to get rid of any details or sharp edges because they're going to be blurred together. Cool. Next we have Gaussian blurs. So these are very commonly used blurs in image processing for a couple of reasons, but one thing is that they're very fast to implement. And yeah, that's about it for the kernels. So we can see we have those exact same kernels right here defined as a NumPy array, right? And then you can apply those kernels using filter 2D, which is a command which filters your image using the kernel. Cool, so I'll go through all of them again here. So we start off with the original image, right? Then we have the sharpen, right? You can see the edges are very sharp here. Then we have the unsharp, which gets rid of edges. We have the box blur, right? It's a bit hard to see, but it's a little bit blurrier than normal. We have the Gaussian 3x3, 5x5, right? My face is a bit softer. The Cerbel filter, right? Which just gives you the edges of the image, right? This sepia filter it's a bit different, but we can basically take the RGB values of the image and then apply some sort of filter to those RGB values, right? Which is going to give you this sort of look here. All right, so it's some sort of transformation on each of the individual pixels. This one's just a fun, but it's just that image plus a bit of grain, and then the threshold. Cool. Now that we've done that, we can move on to camera calibration. But first, do they have?
Not quite.
Not quite. All right. Well, I'm going to walk around for a bit, see if we have any questions, and then hopefully, yeah, we can get food. What time is the estimate? 6.
Around now. Should be
Ish.
shortly.
Yeah, I'll go around if you guys have any questions. How we doing?
Oh, I'm sorry.
Oh, that's okay.
So it's not taxes though.
Index. Oh, you need to change it to 0 if you only have one webcam. Oh, yeah. And then just get rid of that Perlin. Yeah. Or you can try and install it if you want. I don't know if you have Git. No, probably don't have Git. So yeah, anytime there's Perlin, so scroll down a bit. Might just be more. Oh, might just be the bottom. Yeah, it's just the bottom. Sorry. Where the Perlin is. Oh, great. Grainy. Change that to sepia again. I don't know. That should work now. Oh, save. You missing another one? Oh, that. There we go. That should be it. Sweet.
Thank you.
So yeah, that's our image. If you press, I think that's the original image.
Yeah.
So just, yeah, don't close it. So just press any key. It should change. Yep. So you can see the different filters here.
That's neat. Thank you.
Yeah.
Yeah. Nice.
So yeah, it's like those, like old, like photo booth filter thing.
Yeah.
Some computers. Yeah.
Oh, yeah.
It's basically like that. Just show off the basics, but obviously it's just. Hello. Oh, so using resize, so cv.resize. Yes. Yeah, you can resize it. What do you mean resize it? How do you resize that? Yeah. Oh,
So it outputs it. It has an output there. You can just feed that output to something else.
Yeah, so MCR is
Does it have the
from
invasive,
So instead of putting it something, you can put
lecture,
image size. So we can always pass in the input, the output of one filter to a
something
filter.
and it measures your.
It's an invasive device. It invasive measures your blood flow.
You got terminals. This is a Mac. I'd probably just run it through the So where's it saved? Desktop. Yeah. So just go to your navigate to your desktop. Yeah, there is. So in Mac, it's usually saved as it's usually users. So it should be users and so the username, desktop,
Some people like instantly file by file.
and you have stupid access.
I don't know why this is not working.
And so now,
Probably like some.
now we're on your
small-
desktop. So now we can just run Python.
Oh yeah, I'm gonna wait.
Which one? Webcam?
So after line 9,
Python. We should have Python 3.
do CV2 dot wait key.
Sweet.
CV dot wait key.
Oh, do you actually have to like?
I don't think so. I think you have to wait key one. Is it like one? Is it from one? Yes. It's probably not gonna work. No. Yeah, let's get back to the phone.
Oh yeah. So yeah, we're up to date now. Well, we just need to delete. Should we probably need, yeah.
It's just hard because there's so much like other
Oh,
stuff.
you did?
Yeah,
Might be just yeah.
It does one in.
Here, I think. This thing, yeah. And then down here.
You can get like
Yeah, I've already changed the gravy, so.
Yeah. Cool.
CV2
Should be fine.
C webcam.
Hopefully. Sweet. Nice. Thank you. Oh wait.
That's over there. There's what was sample code online.
Should be alright. How long will it take you? Oh, are you having food? Yeah, it should be soon.
I can just run one. Let's go how long? 15 minutes. This part's just running the code anyway.
Here, be there in 2.
Sweet. Okay.
Boy, I have to say your LinkedIn profile is actually really good because, like, when we ran through the clipping, there was no pure whites and no pure blacks. Like, your pro picture is like, basically like the lighting is like all whites.
You guys want to know the least surprising thing ever?
Yeah, so we
Quemar
can
is
use this
best
thing to
friends
stream.
with Chandler.
And this audio passes straight into it.
Is this all muted?
It's on a different scene and it's off.
Thank you for running this. I finished much later than I expected. The death machine wasn't running.
Fair enough.
Now it runs
That's
at
cool
12
because I gotta duck out early, so
Fuck yeah.
give it over.
They 100% work together to make second year ELEC as hard as fucking possible with their best friends. Apparently they were friends before UQ.
What's this?
Quemar and Chandler
Oh yeah.
were friends before UQ.
Oh,
They're
no.
100%. They're 100% trying to make UQ as second year ELEC as fast as possible.
Oh, of course they are. That's how you feel to be.
Alright, should we play pizza time?
Pizza time.
Pizza fucking bang!
Pizza time.
I always do.
Wait, did you order online?
Yeah.
You can request online. Yeah, you should be getting one automatically.
It gives you a confirmation.
We can still request one. You can send an email. Yeah, if you can't figure it out, you can send it. But I'll stack. Where do we go?
Why you guys do photos for our pose in the pose?
Yep, do that all the way.
Oh, yeah, yeah. So if it gets solutions. If one has the number of
Yeah.
So we were like, they've got money, they've got.
What's on?
Oh, no, no, oh, sorry, B, B was. No, so it was so whack, they have to pay the company for voting.
I gotta go print something out. Yep. Unless you want to do it.
Don't do it to
Ah,
I can do it
shoot,
for you.
I didn't. Yeah. Where did my?
You want me to print for you?
Yeah, food to you guys, so come on out if you're hungry.
Have you done, did you bring your student? Am I printing on mine?
I was just gonna log in. Alright, let's go. Oh, where's the printer?
Library.
Yeah.
Oh, wait, mine didn't have it.
No, that's not me. That's not the company. Unless you want to.
Where are you going?
Anyway.
Dinos? Not
Later, we'll
Sorry,
go to-
oh, you know Dinos? Oh. Bro, we started it. Oh, really? Yeah.
Hello. Oh, hello. No one heard that, did they? Da-da. Ba-dum bum 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 bum. That's it.
Miguel, do you want us back?
Whenever you're ready. Probably, yeah. Probably at 7:30. We'll get started by 7:30. So yeah, people can like wander back in. Hello.
I missed webcam, Miguel. Is there
Huh?
anything significant for me to know?
Similar to last year. Who last year?
I'm sure I kind of get it.
Some of the basic, yeah.
It's basically
Some of the code.
it's similar to what we were talking about previous.
Yeah, this is literally, so that stuff is,
Convolving.
yep, FIR filters. Literally FIR filters.
But so when we are convolving with like
Oh, not
this-
that.
or like these ones, they're convolving across rows.
Yes, rows and columns. So in your assignment, it was just across the rows technically,
Yeah.
with obviously
The window.
the wing, yeah. But this case we're just concatenating both across the rows and the columns.
So this will show like different effects.
Sorry?
This will show like different effects.
Yeah. So if you actually look at them, you can see the FIR. So look, having a look at this is the, you know how we have like impulse response? The FIR filter is the impulse response. This is what we call, not the impulse response, we call it the point spread function. It's the same thing. It's an impulse response.
Are these like kind of guessing checked until it works, or like
No, well these,
are they getting?
so this one's derived, the sharpen kernel is derived from the edge detection kernel. So if you have a 4 in there, right?
Yeah.
You can do an analysis. So changing that to a 4, what's the DC gain of that filter? Yep. It's 0, right? That's just the sum. So that means that with the DC gain of 0, that's a high pass.
Yeah.
Yeah. So because it's a high pass, that's adjusting the edges. But then if we add 1 to that,
Sorry, what's that?
well, the DC gain, that means that the gain is 0. That means the DC gain is 0. So the low frequency is going to 0.
Okay.
So high pass.
Right.
Yeah. If we add 1 to that, then it's going to be not quite a low pass, but it's going to be a high boost.
Well, yeah. So this is like kind of like when you apply it around, if it's like equal values when people start using it,
Symmetry, yeah.
then it like cancels out. Whereas if it changes,
Sort of, yeah. So if we have a look down lower, the Sobel filter, that's like a difference filter. So that's taking the difference between the 2 neighboring pixels. Yeah.
but I mean, this one's like, let's say we apply this in just one color, you just get all black, right?
Not quite.
Because I guess you can both.
Yeah. This would be like, it'd be like adding the edge image. So you get the edge image from by taking.
Like, let's
Yeah.
say you just had a green, all green, every green. And you apply
Oh,
this.
yeah. So okay, with these ones, it applies to each color independently.
Yeah.
Yeah.
But let's say we did just have like every RGB value 0, 0.
Yes.
And then type with this cancel it to 0.
Yes.
So it was black.
Yes. So that's the high pass.
Yeah.
Yes, that's correct.
So
Except the
yeah,
edges. Yeah.
that kind of makes sense.
Hey guys, we're gonna get started with the next part. So, down your pieces. It's just iterating. Oh yeah, so this is the part that. Yeah.
There might be in the recording here that this is a little
You what? Hello. Yeah, so for those of you coming back in, we're just handing out these checkerboard patterns, right? So they're pretty important in this next step. We don't have chess. We have check now. We don't have checkers. No. So this is what we call a calibration grid, right? So what does that do? That tells us, I guess, something objective about our environment. So when we're looking at these things through a camera, we know what the dimensions of these squares are, right? So that gives us a little bit of information about the camera itself, right? And what we can do is we can run our camera through a calibration sequence, right? And that tells us the properties of the camera. So I've been talking about cameras all this time. So I might do a brief introduction on that. And for those of you, I might have to resume this. Oh no, still streaming, sweet. Click this back on. Hello. Nope. That's better. Let me a sec. I'm just gonna reconnect this here. And I'm just gonna change this up to laptop. Where is it? VS Code. And actually, I'm gonna have a go through this PowerPoint a little bit. Cool. So I know we're in UQ Mars and not the Photography Society, but I thought I'd talk a little bit about how cameras work. So do you guys know how cameras work at all? No? Okay. Essentially, in our camera, right, we have a sensor, right? So can we all see the sensor here? Right, that sensor allows us to capture details about an image that's coming into it, right? So that's what we're seeing in real life. That's going through a lens, and then it's getting digitized, right? So it's recording the photons that enter and converting that into some digital information, which we can use to turn into oh, I did not, thank you. Sorry, I forgot to change. So yeah, we can use that to, where is it?
Just down the bottom left, yeah.
Sorry, there we go. So yeah, we have an image, right, which we get from light in the real world. And that amount of light is affected by a couple of things. One of them is the opening of the front. So if we can all see here, right, there is an opening in the front. And as I change the settings in this camera, right, I can make that smaller. Can you all see that? So I'm basically changing the size of the opening, which is letting in less light. All right, you might be wondering, why is this important? Can we see that? So I'm changing the iris. This is called the aperture. Why is this important? Well, when we're dealing with images, we want the things that we're trying to analyze to be as in focus as possible, right? We don't want it to be blurry. And so one of the trade-offs we make is aperture. So the more we close down this aperture, the sharper generally the image gets up to a certain point, but also the less light we can let in. So we'll look at this. It's sort of changing the aperture. So this is wide open and then closing up. Do you want to have a look? So far away. Come back, yeah. So we're changing the aperture. Cool. So one of the trade-offs we're making when we're designing cameras to be used in computer vision is choosing the aperture size so that we can get a sharp and clear image of our entire scene, while also letting in enough light so that we don't get too dark of an image, right? So obviously, if our image is darker, we won't be able to see everything in the scene. So how do we compensate for that? Well, one thing we can do is change what's called the shutter speed, right? What's happening when you're taking a video or a picture is that the camera is either electronically or mechanically moving a shutter up and down and recording an image for a certain amount of time. So we can see on here, these are the different shutter speeds, right? We can go from 1/250th of a second to a whole second, right? And that's another trade-off that you're making. So the faster the shutter speed, the better, right? That sort of makes sense. If we want to capture an image without any motion blur, we want to like freeze that moment in time, we want a really short shutter speed. So like 1/250th, 1/1000th, right? But what's the issue with that? Well, the less time we open that shutter for, the less light is going to go into the camera, right? Which means that we're going to get, again, a darker image. Does that sort of make sense? Yeah. So again, we make that trade-off between shutter speed, motion blur, that sort of thing. But in general, if we're doing things, we want to minimize that motion blur, right? Because motion blur is going to cause, I guess, errors. Oh, sorry, not errors. It's going to cause error when we're doing things like object detection, right? It's not going to be what it looks like when it's still. Cool. And the final part of cameras I need to talk about is what's called the ISO. And that's just a fancy word for gain, right? So how many of you have taken like Eng 1300? Or how many of you have played with like an electric guitar or something like that? Yeah. So gain is what we take our original signal and we scale it up, right? But you can imagine that that original signal also has noise, right? So that could be due to the temperature, some electronic issues, right? There's always going to be some sort of noise level in that image. And what we want to do is we want to boost the entire signal up, right, including the noise. And we can see that the darker our images, so if we have a very short shutter speed and a very closed up aperture, then we'll have a lot of noise in comparison to our small signal, right? Which means we'll have a very noisy image, which I'm sure you've all seen if you've taken a photo with a phone, right? So in contrast, if you have a lot of light in your camera, so a very open aperture and a very long shutter speed, then you're going to have a lot of your signal. You're going to have a lot more light that goes in, and so you won't have as noisy of an image, right? But again, we make that trade-off. Cool, so that's, yeah, basics of camera basics, and that's the basics of what we call the exposure triangle, right? And yeah, you might see this a bit later. We'll have a bit of noise in our images, but yeah, cool. So next, what we're going to do is we're going to perform a camera calibration. So if you go to, why can't I scroll down? There it is. Go to your camera calibration code and you can run that. Hopefully it works. It should pop up with a webcam. Hopefully. Not that one. So yeah, you can run the fourth demo, camera calibration. And what you want to do, and it's a bit tricky, but you want your webcam to be looking at, not this image, at the image of your checkerboard. Yeah. Come on. There it is. So it'll be very slow. And I'm kind of lucky that I was able to have a external webcam. But if we have a look, oh, it should come up with something like this. Yeah? So, yeah, this is one thing you have to watch out for. Try not to bend your piece of paper when you're showing it to the camera. All right, and what this is doing is it's using edge detection, or using those image processing techniques from earlier to find the edges, or sorry, find the corners of this checkerboard. Yeah. And then from that, it's actually capturing images of the calibration, right? And so what I want to do is basically move my webcam around, or move your checkerboard around, right? Until you can collect enough data points, right? And it's a bit hard to tell here, but yeah, try and get a variety of angles. So I'm trying to do that here. So move in and out, go really far away, stuff like that. And that'll give you a calibration of your camera. And then when you're done, just hit, what's the button? You can hit Q, sorry. When you're done, make sure you hit Q. Q. And it might take a little bit to process. Q. Why isn't Q working? Okay, hang on. One sec, why is this not working? That should be working. Why is that not working? Oh yeah, it is working, sorry. So yeah, once you've collected enough images, you can press Q and that'll end the process. And don't interrupt it yet. It's going to perform what's called, yeah, this camera calibration here, based on the images that you took. Yeah. So just give it a minute to process. If not, I do have some pre-calibrated ones. So what this is going to return is a set of calibration values, essentially, right? So if anyone's done any, it's not working. If anyone's done any anything in, I guess none of you've done computer vision before. Anything robotics? I'm guessing you probably haven't done that either. It'll basically return a transformation matrix, right? So I'll show you what that should look like here. Can't show that. Never mind. Sorry, I'll walk around if you have any issues. Looks like people are not sure. Did you forget to change the video capture object? Did you get a paper? No. Who is missing a checkerboard? No one? Is it frozen? What'd you press? Yeah, no, don't cancel it. It's just very slow. Yeah. Sorry, this process is very, like, computationally intensive. Might have to do something to modify the code. Hang on. Yeah, I might just modify this code a little bit to make it a bit easier. Okay, I'm just gonna add an extra bit to the code. Okay, let me try and rerun this code. This might make it slightly easier to do. Yeah, there we go. Ah, sorry, not Q. Space. So what I'm just doing here is I'm checking if I'm pressing spacebar. So I recommend you add this to your code. Sorry about that. And this is gonna make it so that it'll only use that calibration if you press space. So I'll do it again. It's gonna take a couple images here. I think you only need like 3 images technically, but. So again, you can see that there's some motion blur in my camera, right? Okay, let's try that now. Oh, calibrate. How is it not? Oh, sorry. Am I using the right? Yeah, I'm using the right one. Why is this open here? I don't want to print. Go away. Oh, this one. Yeah, come on. You can do it, camera.
Why is the frame rate so slow?
Because it is. It's got to run a lot of
That's the
calculation.
program now.
Oh, that's fair.
Why is it so hard to? Oh no! Don't tell me it does that. Oh, that's so annoying.
What's what?
My phone webcam.
Yeah.
Okay, I'm gonna try this. Please work. Yes. Okay. Sweet. This worked. I think. So if it works, you should get a thing pop up called image undistorted, right? Thanks. Oh yeah, these are my hands.
What's the
Yeah. Yes, yes, so. Yep.
Is there a way to like visualize them?
That'll be in the next step. Those are NumPy things which you can basically save and then import to a different thing. Cool, so if you've done this right and you've gotten some calibration out of it, you should see that your directory has a bunch of extra files in it called, I think, mtx.mpy. Like, essentially, those are NumPy arrays which you can save to your actual directory, right? And we're going to use those values, which are our calibration values. We're going to use them in the next step, which involves these fun things here. How have we gotten? Yes, we do. So, yeah. For those of you, keep trying this camera calibration step. Otherwise, maybe in a couple minutes we'll share we'll just share the values for these NumPy arrays directly, right? Obviously, they won't be accurate calibrations, but there'll be some calibrations. All right, so I'm going to run the next step, which is Aruco tags. So let's talk about those in just a sec. Cool. So have you guys ever seen these before? I mean, if you've looked at the last one last year, probably, but Tevin, have you ever seen this before?
I have not seen that before.
Ah, damn. What is that? Whoa. Yeah, this is it. These are Aruco tags, which look a little bit like QR codes, and they sort of are like QR codes, right? These essentially are a recognizable shape that, they're a standardized recognizable shape that OpenCV and most computer vision libraries will be able to recognize. And the nice thing about them is that they are not rotationally symmetric in any way, right? So from this, since we know the size of the tags, if we take a picture of it, right, we'll know exactly the position of this tag relative to the camera that took the picture. Yeah? So you can imagine how this could be useful in computer vision. Like if you attach this to, I don't know, some object that you want to track, you could track the position of that object in real time. Yeah? So we actually use this quite a lot in research as well, as Shenka might want to talk about. Yeah? How do you use Aruco tags in your research?
So we've got two depth cameras for our thesis. We're using the Aruco tag to get like kind of localize where this camera is relative to the other camera.
Yeah. We can also use it with like robotics. So in that case, they've attached an Aruco tag directly to one of the robots. So we're able to track where the robot is relative to the camera, right? Which is important if we want to send commands based on what the camera sees. Yeah. So yeah, Aruco tags. And yeah, unfortunately, we don't have scissors, but if anyone has scissors in the room, it'd be nice if we could cut these out. If not, it's fine. It's fine. So yeah, OpenCV, they can recognize these Aruco tags, right?
So don't worry too much about the code in here, but essentially this code, this part is detecting the Aruka tags, so detect markers, and it's giving us a list of the corners of these tags, right? So each of these tags has an origin and sort of a transformation associated with it, right, relative to the camera, right? And so yeah, let's have a look at this. Hopefully I did this right. We'll see. Come on, please run. I might have to copy. Yeah, hang on. Please, 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 please. Is it gonna run? Nope. Well, sort of. It's weird OBS. Is that gonna run? Nope, OBS still. Sorry, my computer does this weird thing. I've installed like OBS to do like streams like this, but it's for some reason it always like overrides my default camera. So I think I have to change this. Let's try that. Cool, that should work. Yeah. So hopefully, yes, sweet. So you can see here, right, it's able to identify the corners of this. Yeah. And track where the location is. And did I do that with, am I running the right one? Hang on. Yes, I am. Sorry, this one here. And I think, what's it looking for? Ah, okay. So this will only, for some reason this will only work when there's two of them, so I might have to cover. Let's cover these. Cool, there we go. So what this code is doing is it's finding the distance between two Aruka tags, right? This is just one example of what we could use these for. But this basically allows us to track real world positions using a camera, right? Because when you think about it, there's not really any real information from the camera itself, from the image itself, right? If we don't have any real world reference, we can't get any information about the real world geometries. Yeah. Cool, so what you can do now is try to run that code. Just, yeah, raise your hands. Who was able to run that last camera calibration step? Yes, one person, two people, three. Who's still stuck on that? Because I'm just hoping we have very similar webcams. All right, I'm gonna chuck around a USB, and we can, yeah, I guess share across the, just the NumPy vectors, because sometimes the cameras aren't working very well.
Oh, okay. Yep.
I'll just do it in mine. All right, I'm gonna copy across this USB. Don't worry, there's nothing on it. Just what's on it? Nothing important. I'm just gonna pause the stream for a sec. Just in case there's stuff. Yes, I'm just gonna copy these across here. Where's the Mars demo? Demo. So we should only need these two. Cool. Let me just get rid of this. Here we go. Here's my USB. So who needs the calibration stuff? No, do you guys need it? Have we all got it? Are you still trying? You give up? It is hard because it's just very competition. Otherwise you can share it across, I don't know. What's the error?
Just
Hmm.
dictionary. Oh, sorry, no, that was me trying to. Dictionary has no attribute.
Dictionary get. Oh, that might be. Hang on. Wait, dictionary get. Oh, that's why. Where did the get come from?
Oh, the get was I changed it to dictionary.
Oh, was it there? Weird. Might be. Might be like an extra Python. Yeah, pip. Maybe. No, contrib. Contrib. Do you mind if I just quickly look some? Do you have? Oh, you got Chrome. Sorry. Might be a weird OpenCV thing. Oh, OpenCV contrib Python.
So it's this script is using the calculation.
Yes, yes. Sorry, I missed a step. Cool. So, if you guys are getting errors for that one, you might need to install. Sorry, I'll plug it back in. You might need to install this thing called OpenCV contrib Python, which is just a few extra libraries that we might need. So, pip. You didn't. What's your version? Is it 4.6? I don't know why that's giving an. Yeah, Python. Sorry. Is anyone else getting that error for the next task? Yep.
Well, yeah, it's just saying that I can't load because it's missing this. What was it? What should we? It's missing this. No such file as like this.
Oh, yeah, that's the file that we need. Do you want it? It's on my USB. Are you getting the error as well?
I'm getting good.
That's weird. That's not. How are you running it? Python 3. Yeah, that should be working. Aruco demo. cv.aruco. This is not a function. Hang on. Oh yeah, what's the, sorry, not the Python version. Yeah. Did they change it in version 6 to 7? I swear. Hey, are you getting the same issue or is something else? Ah, okay. So opening a Python or just the?
Just open the.
Oh, the directory. So
Oh yeah, it's changed.
should be in. So change directories, and then you change to users to your username, and then you save it in desktop. Where'd you save it?
Yeah.
Yeah. So yeah, that's changing directories, and then we can just run by doing Python 3, and then yeah.
Yeah, it's changed.
Okay. Sorry, apologies if anyone's having issues trying to run this. Apparently, they changed the code from version 4.6 to 4.7, and it's instead of doing dictionary get, it's .get. So yeah. Oh, we're trying. Okay. So yeah, it's a slight difference. Doesn't work. Never mind. Sorry about that. I don't know when did they update OpenCV. I swear.
cv.aruca.get predefined dictionary.
Okay. Get predefined dictionary. Sorry. Yeah, you might have to huddle around here. Oh, this would be a good photo shot, wouldn't it, Jay? Change the aperture, Jay. I told you. We talked about it in the workshop. Yeah? I said we need the aperture to be different so we get more things in focus. Yeah, I said that in the lecture. I mean the workshop. I mean just kidding. Yeah, does that work?
IDs can be rejected.
No, it shouldn't change it.
Yeah, all this has changed.
Oh my god. I wonder if it's possible to reinstall a different version.
It might be, yeah.
Oh, yep, that's right. So that's because, nope, that's just, so we can edit that, where is that file saved?
It's just here.
Oh, sweet. Oh, yep. So we just need to change this to, change this video capture. I've got it set as 1 because my 0th camera is like something else. But yeah, that should
and then run again. I don't know why that doesn't work with idle. It's weird.
Oh my god. Yeah, so this is like in the 70s or 80s.
Who's that?
Who do you think?
I don't
It's
know.
Ahmed Amin.
I don't know what
This is the
minute.
first pick, right? And then what it really looked like. Cropped out. type media
Anyone still having issues? Oh, I can't believe they changed the root code on me. It's not dot.
He
There
said
is
it only
a,
works with 4.6.
it does work in point.
Do you know why you're running?
Yeah, apologies. I forgot that they updated OpenCV. You might be able to install. Hang on. Sorry. Okay. Can you send that to me?
Like I did the roommate Louise again. Yeah. He leaked this photo into my group. And then I say, oh yeah.
Yeah, here's my first ever Wikipedia connection.
You really? He loves it. You got one question. I did this like hang out. Wait, can you give me the plus 500?
Sorry. Yeah. Yeah, just Messenger. Yes, apparently. Yeah. I just changed it. Oh my god. Oh, just the whole thing? Yeah.
What do you do?
You just need to change a few things around. I'll see if this works. This might break it, but we'll see. Yeah, this is unexpected. Pip3 install.
Need to help people.
Huh?
Need to help people.
Yep, now I'm...
Yeah, that works.
Yep, new Python version. New OpenCV version. And what is the thing?
I think turned off.
I know. It's because I had... Yeah, because I don't want to know. Beautiful.
Wait, tell me what to change, yeah.
I'm
Get
putting it up
predefined.
on here, yeah. Hang on, what's that? I think it's just this stuff.
You just find that in the documentation.
Yeah. Let's try this now. Please work.
Run as his admin.
Run as admin, maybe. Yes, okay. This works now. Okay, so, sorry. For those of you who are having issues, yeah, they changed the name. Instead of dictionary, it's now predefined dictionary. I think that's it. I think that's all the changes. Yeah, just basically replace the code with this. So I'll show you what the code was before. Just, yeah, basically replace these with that. And this should work, hopefully. If you're still having issues, Shankar will help you out. He's a brilliant teacher. Yeah. My mentor, Shankar. Oh my god.
It's seemingly
That looks funny. Yep. So that happens when you're... That's pretty funny, actually. So, okay, when your camera calibration doesn't do right, what it does is it tries to understore your image, right? So your image will have one or two things. It'll have pin cushion distortion, which is when it looks like really smushed in. You know, like those filters, yeah. Or it'll have barrel distortion, where it bulges outwards. What's happening here is that it thinks you have pin cushion distortion, so it's trying to bulge it outwards. So, I mean, you can run it again. So this is already the undistorted, but you might want to run it again. That's pretty funny, actually. Well, yeah, you learned stuff about it. Yeah. Hello, hello. For what? So for those of you still struggling to calibrate it, I recommend making these couple of modifications to it. So just add this bit in, and then indent this. So you might have, yeah, these ones here
normally just run every single iteration, but instead what you want to do is you want to check if the space bars are being pressed with these two commands, right? So it's going to check the key that you press in like 1 millisecond, so maybe change this to like 12 or something. That's going to check that if a key is pressed, and then if the key is spacebar, it'll then append that data point for your calibration. And this allows you to limit the number of data points going into the calibration, which means that it should speed up the process a little bit. Yeah. So yeah, try and add this modification. Otherwise, you can just steal a calibration from someone else. Tevin, you got them? Have you got the calibration stuff?
I'm just appreciating this holy photo.
Okay.
Just one last time. And I'll stop playing sexy.
Okay. You don't have the USB?
Estimate codes about
Okay. Oh, yeah. Yeah, so install OpenCV contrib.
just dash contrib.
Oh, sorry. Yeah, OpenCV contrib Python.
Just run that. Oh my god.
How we doing?
I'm just, what'd you do to make it slow?
Oh yeah, so add this wait key thing in. So it's gonna check the key that's pressed, and then if the key is a space bar, it's going to then run that. Otherwise, don't do anything. Hey yo! Oh my god! Oh my god!
I'm not gonna lie, man. Why
What's this kid doing?
why did you code it so that it would take like 1 million images?
Because I forgot to change code from last year. I mean, usually, like my computer can usually handle that many images, but not everyone's can. I don't know. It's fine. How we doing? Oh yeah, if you bend it. Sorry. OpenCV contrib Python. I think that sometimes fixes the Ruko stuff. This is the camera calibration. So not yet. It's the next one. Yeah. Yes.
The square.
At all?
It-
Oh, is this when you add that space thing?
It was before, but it's not now.
So you have to press space. It'll only display when you press space. Yeah. So you have to hold it and then press space to when you want to take a picture. And it should. Yeah, yeah. Probably like at least 10 with some different angles. If your camera's already pretty decent, so yeah, it'll only work when there's an image displayed on it. Yeah, like that. Yeah. So take a couple, and then try to move it out like further away, and that should be fine. Try running with that.
And now what do I do?
Press Q now, and that should calculate something. Yep, that was good.
Okay.
That's it, and it should have saved the undistorted. Sorry, now you have to run the last one. Yeah. Just Control C. Control C the. In your terminal. Yeah. Yeah, that just go, or just restart it. Yeah, yeah. Is that not working? Oh well. Press, yeah. And then run the next one, and then that should.
Okay, next one.
Yep. And then for this, you might want to cover up the other tags except for 2 of them. Because it only works with 2.
I'm getting an OS error. I don't think it works on Windows 11.
Skill issue. No.
Why is Windows?
No, have you Windows 10?
Yeah.
Okay.
Yeah.
Oh yeah, sorry, you didn't have the last code.
Surely use
VS Code.
Yeah.
Yet.
I'll send you an invite.
Dinos?
So I've got a barbecue thing. So before Metaphor 1.
When?
So I'll go to 8 a.m. 8 to 10 Friday. Yeah, 10 to 12. Me and Michael will be grilling.
Sweet.
help us.
How we doing? You like my camera?
Yeah. Bro, you bold zone it as well. Yeah, you're welcome.
All three. I mean, two of them.
All four of them, bro.
Yeah. Wait, that was out loud. Hello.
Wait, oh no.
Shadow play. Alright, hang on. I'm putting this away. Hang on. Just in case this says I'm skin.
So the origin story is a little bit sketchy, They do it all, but like they don't like their hardware. There's like 3 guys who are like all but there's like 3 people who just sit there on the SPC for his month. He just it's so close to the TV, trying to read and just in there doing that type of goals. They have a literal people are like it's just like no knowledge of the engineering side is really good. Yeah, it's really just taking this spell. Just trying to really goes down to the box. Yeah, there's one like honestly small companies normally they'll get a contract. Yeah, there's like they're not like a large. Please, it's normally just
Whoa, I'm in the US. Hey. No way.
I was working this little thing where they were this unique simulation of like a code excavator, and I was changing.
I don't want to go through it.
For that, I like anything that changed on their company, I just pulled it out and changed it.
I have a
We just made it
Is the mic live?
And was this all Honey Godly? Was this on Honey Godly?
I couldn't actually change the original file because it was back on the right. So I just figured it out. Instead of taking well, oh, yeah, so that's also what I was saying. That's like, literally almost every person public all these variables, all functions. Yeah, like, I mean, I try to make like junior stuff and like, bro, like, just but like, it's kind of like, realistically, they're not like massive juniors, they're like bunch of developers. If you can just kind of explain to the guy next to you, it's not good, but like, just like to try to
Two engineers.
and then just add like extra tracks and then just get like
I don't think calibrated would impress you.
they make it super fast, just like a big computer.
And calibrated image.
And it's like realistically, that is a cheaper solution rather than spending the time to like do it in C++, just to make it harder. So like the spending on the business, like all of business implementation, it's like
That's how they did the they use that sort of stuff.
instead of like making it free. think I've seen it. Very small. It's a public school. How you doing? So he's talking. We go. We keep going.
Sorry?
We keep going to the rest of the files.
I think that was it. Oh, we have one more, but we don't. That's like a bonus one. We don't need to do that one. Should I do it? I'll do it. All right. I did include an extra one here. Not really necessary for computer vision, I realize, but this is a histogram. All right. So you guys have all heard of histograms before, right? So this is taking the number of pixels in the image of particular RGB values, right? So 0 being really dark values and 1 being very bright values, right? So we can see there's quite a lot of pixels in this image that are very close to the maximum value, so which we see the spike here. Actually, I made this spike really small, but it goes all the way up. Yeah. We also see in this lower region, a lot of the darker colors are more blue than any other color, which is probably due to the ground, sort of bluish tint. And of course, we can see a spike around this center, which is all the grayish values. All right, we can see it's slightly more yellow and green than blue. Yeah. And then in this other one, I've just modified this image. Actually, that's not drastic enough. Let's change this to 0.1. Oh, why is that not changing? Yeah, I don't know why. I think that's just because I exported it with my Lightroom or something. Image out. Oh, I didn't recalculate it. Lol. No, this should be it. Yeah, that should work. Anyway, yeah, this is just an extra thing. We don't really need this, but if you want to run that, it's on the GitHub. I will go back. Someone had questions about this this demo here. Cool. So for those of you who have updated to OpenCV 4.7, you'll need to change these to. Sorry, I changed it here. Yeah. So you'll need to change it to, instead of just get dictionary, it'll be get predefined dictionary, and you'll have to add these extra things. So just comment this out and run this here. Cool. And that should work. I mean, it's worked for other people. So. Yeah. Okay. I'll show you a face recognition example. I forgot to put it on the GitHub. I'm sorry, but I will show it. Where is it? Yeah.
Well, you know what I am? You know what I am? Hey, you know what I am? Mechatronics. And I had to do this in here.
Fortunately, this one's not working that well. Cascade R. You know what it is? It's this thing. Alright, I'll show you some face detection. Cool. Yeah.
That's a new Tinder profile.
So yeah, this is a bit of face detection. I will put it up on the GitHub. I forgot about that file. I'm sorry. So it's doing its best. Right? It's got some false positives. Right? Don't be scared about the weird face that you see outside. I promise it's not real. Oh wow, look at this blur. Look at this blur. Yeah. So yeah, again, this is just finding a region of interest. Yes, I will put this on the GitHub. It's not on there right now. I forgot to put it on. But yeah, I'll show you what it's doing. So it's creating a rectangle, but we can do a fun thing here. And what I'm going to do is I'm just going to blur this out. Equals image faces dot. Sorry, we'll end it off here. I'll stick around if you guys want to stick around, but yeah, that was the bulk of the workshop. Thanks for coming, guys. Just give me. This is cool though. This is cool. Give me a sec. Gaussian blur. Image faces. 3 sigma. Okay. So I'll do a blurring algorithm. Missing. Oh.
Thank you everyone online watching, and thank you everyone for coming. We have a networking night on Thursday. There'll be many different companies, Arm Hub, different companies from River City Labs, Cormatic, I'm trying to think, Engineers Australia, BPEC, Micro Melon. I think we have something like 15 companies coming. It'll be good. Please come on Thursday. Next week, Pauline Pounds is going to talk about making drones work autonomously in the air. So come and see that.
Yeah, how'd you link your
I'll be there on time next week.
Your laptop.
Mac.
Networking nights at River City Labs.
Oh, because
Only
it's
in
like,
Mac.
it's like airdropping to each other and shit.
Yep.
So,
Everything works on Mac and iPhone,
there'll be
unfortunately.
yeah.
Yeah.
Valley won't be anyhow, unfortunately, but I will be getting blitzed after.
Come on. Ah.
I wonder if it's possible to do it Bluetooth and Android. Yeah. Or like, is that just not possible? Because like Bluetooth is like fucking radio waves.
I've got a small announcement. Separate TQ Mark.
Oh, Neurotech.
Get a load of this guy.
This guy. Not so good.
Next week there's a new